Hi, everyone. It's great to be here. I've had a lot of really interesting conversations the last 2 days, and that's been a lot of fun, so thanks to the organizers and everyone. So I'm here to tell you a little bit about Protocol Labs, which is where I've been working for the past year, just about a year. Before that, I was a computational neuroscientist at Columbia, and so this has been a bit of a transition. And what I've been doing is focusing on how to sort of raise the tide for all of neurotech with a focus on BCI and Neuro AI. And we're doing that through funding and both venture funding and grant funding and also different field building activities. So let's see. This is our vision that we've developed of what the future could look like for this ecosystem. The way I conceptualize this is across a few different axes. So right now, you can think of the domains of neurotechnology. This is like one way of dividing up the space as ways that we interface with the brain. And so I'm putting cochlear implants, DBS, and even things that people might think of as quite modern cutting edge, like modern motor and speech BCIs that Neuralink and other kinds of companies are developing. I put them still in the today category. These are real technologies today that we understand how to build. We have AI that sometimes behaves like us, and we have worm and fly connectomes, which of course is a major advance, the fly. But where we want to go in the future is doing something with neural interfaces that looks totally different. That's co-processing information between brains and machines in a way that's much more than, say, just speech or motor readout. We want AI that behaves and thinks like us, not just behaves like us. And ultimately, we're interested in getting to this, very long time scale potentially, but the idea that we could emulate whole humans, even specific individuals. So one of the things that I think is interesting about the field is that there's a lot of technical optimism. I think people here are quite grounded, actually. But if you look at the popular press and so forth, you'll kind of get the sense that all of this is about to happen, but there's like no appropriate respect for how hard it's going to be. And so one of the things that we've been doing at Protocol Labs is trying to emphasize that there is really meaningful, hard science that has to occur in the interim, and we want to make sure that that science happens. And so instead of having this miracle, the proposal I'm making is that we need to have substrate-independent theories, or at least models of intelligence. I'll get a little bit clearer on what I mean by that in a second. But first, I'll just mention different sources of data that, of course, could inform intelligence science. We talked about connectomics already and what you can get out of that. There's also neural data. The neuropixel revolution has really changed things, as have optical recordings and so forth. And then you care about behavior, because ultimately there's the whole structure to function axis that needs to capture all these things. Sorry, let's see, do I have to click on this for this to play? This is my, and Tomos, maybe I should mention it's Tomos, a collaborator at Harvard who captures the poses of animals freely moving and then instantiates those in a physics simulator and builds controllers such that the embodied virtual animal can actually match the real animal. I think Tom is going to show you cooler videos than this in a few minutes, so I'll just go through there. So just getting back to what I'd said before, in order to get to this set of next generation neurotechnologies, we need to go through data and then we need to go from data through theory. And I'm open to the idea that our appropriate level of description in this middle stage might still be somewhat poorly interpretable, but it needs to have features that are highly useful for us to build products and technologies. And I'm proposing that the neural data foundation model framework is one that might be the right level of description. These models have three properties. They are predictive in time, in the future. They have fill-in across brain regions. And they give you a common mapping into a shared latent structure that is common across subjects. This is necessary for building, say, agnostic decoders. In fact, here is an example of the foundation model unlock that, this is in a much more impoverished system. Kudos to David Cicillo for building a first commercial product in neurotech. Stand up and take a bow. Apparently, it's hard to buy because people are buying it. So what are we looking at here? This is the number of people, or you think of it as hours. I think it's 3 hours per person. The amount of training, pre-training data on a model that does decoding of character level performance from the wrist, and what the performance is on the generic model for a new individual held out from the training sample, and then how much better the performance can get when you fine-tune on a new individual. And of course, you get better with fine-tuning, but the interesting thing here is that the red and the black lines actually will meet. They have different slopes. And in fact, internally at Meta, David confirmed this morning, but I'd heard it from others as well, that they are able to do decoding without any fine-tuning. Okay, I was like, am I out of time? How much? I have 1 minute? Okay, you know what? I'm going to skip this then and go to here. So we have an idea of the ecosystem that we want to exist in the world. And it starts like this. We think that there are intelligent scientists. Many of them are here in this room. They can be in companies. They could be in FROs. They could be in labs. And I want them to inform the people which will have the entities which will have the most privileged data in the ecosystem. And those are the invasive BCI companies. I want to inform them of what data will be most valuable for the kinds of neurotechnology we want to build. Then, hopefully, those companies will be incentivized to share their data back with these intelligent scientists such that they can build these predictive models that we discussed. Why would they be willing to share their data? Well, because actually you get this foundation model unlocked for their devices. Their devices become more valuable because they have foundation models in the loop. But those levels of description encoded in these foundation models allow us to do lots of other things with downstream technologies. One of them, not the only one, but one of them is to build more human-like AI. And the utility of that is that it unlocks capital flows into the field. So if you're making these companies' products better, they're going to finance all of this activity. OK. I'm going to skip all this. Well, actually, I'm not. We want to have, in 5 years, 10,000 people with high bandwidth BCIs, 100 million hours of data across invasive and non-invasive modalities, and a mouse connectome. This is what PL is spending money to do and organizing people to do. And then Uncle Juan wants you. I actually didn't know Molly was going to be here this morning when I made the slide. So now someone's going to go back and tell Juan that I made this slide. Hopefully he's okay with it. We're real. So Juan mentioned this in his talk yesterday. We are very interested in trying to build a network of people that are involved in this community so that the entire community can work better. And we are willing to finance part of those interactions to the extent that that helps with the network dynamics. So for example, I'm putting together an advisory board for us to get input on what should be the most useful things that we do. These are just a couple of examples of the kinds of people that we will have on there, from field building like Adam, from BCI community like Eddie, or from the AI community like Greg. There will also be a diligence team. I did a session yesterday on this. All of you and your colleagues who want to help me and others on the PL team look at what are the best and most appropriate fundable projects, and can we use our ability to do expert diligence to encourage other funders to bring capital into the field. Let's do that together. We are going to have to be more systematic about how we give out money. Right now it's basically how I'm feeling when someone asks me. So just so you know, that's how I've been doing it for the last year. It's probably not a good scalable solution. We want advisors, for especially the startups and FROs and even the labs, right? How do we talk about this stuff to the world in a way that's optimistic and not scary? We actually have people in our network who are thinking very hard about this problem, and we can provide that to you for free by incentivizing them to work with you. And other aspects. We want to get as many funders in our network as possible so that we can coordinate capital allocation. And then, of course, the companies and the labs and the talent. I put Neuromatch down here. This is not exactly this is not anyway, Neuromatch has a lot of talent in it, but that's one of the organizations we're working with. Patrick, myself, and a few other people in the room have worked with them in the past. But yeah, so one of the things that I'll be doing after this meeting is reaching out to many of you and asking you actively to come and participate in activities that we're working on. So that's my time. Sorry.
Thank you so much, Sean.